Welcome to the Commercial Lighting Commissioning Technician course. And now, on to the basic methods of varying our lighting output, known as dimming. There are several methods of lighting control available to us. Today we'll be discussing non-dim switching, mechanical control, sinusoidal control, forward and reverse phase dimming, using a control voltage, low voltage switching, and a variety of control signals. The easiest way to control a light is to switch it on and off by applying and disconnecting electrical power. All electrical lights can be controlled this way, but of course, this does not give much variety in lighting output. A creative way to control lights which cannot be dimmed is to use mechanical devices that will intercept or divert the light before it exits the fixture. These can be seen in sporting arenas where the HID floodlights have to be dimmed for artistic purposes. An easy method of reducing the light level is to reduce the amount of voltage that is sent to it. By using a transformer with a variable tap attached to a wheel or lever, the overall amplitude of the AC waveform, and hence the voltage, is reduced from full down to none, and the connected device will emit a proportionate amount of light. Unfortunately, this method is very expensive and bulky to build, and has very few methods of remote controlling the level. The next method to control the amount of light is one of the most popular since it can be economically manufactured into a relatively small package. When using forward phase control, the sine wave of alternating current is examined to locate the time when the waveform reaches zero. This location on the graph is known as the zero crossing point. The electronics then wait for a very short period of time and use a switching device such as a triac to turn on the output. The output is left on until the zero crossing point, and then it turns off. This process of switching and turns off happens 120 times per second. The remaining area in the waveform, as seen in the shaded portion of the diagram, will then make up the total amount of energy being sent to the fixture. Although this method works very well, the sharp rise of energy that occurs when the switching device turns on will cause a jolt to the circuit. This can cause issues when connected to electronic devices, or can also cause the lamp components to make a small amount of sound, referred to as filament buzz. In order to mitigate filament buzz and eliminate the sharp rise in voltage, it is possible to create dimming equipment that works opposite to forward phase control. This method is aptly known as reverse phase control. In reverse phase control, the waveform is switched on at the zero crossing point, and then off after a short period of time. This creates a similar alteration to the total area of energy being sent to the fixture. Although somewhat more expensive to manufacture, reverse phase control dimmers are compatible with many more devices, including dimmable electronic low voltage controllers, and are far less prone to creating filament buzz. For fixtures that do not easily support forward or reverse phase dimming, they may use an internal circuit to vary the lighting output. This is sometimes known as 4-wire control, where the fixture is fed a constant 120 volts for power on 2 wires, and uses a second pair of wires to receive a low voltage signal, which is representative of the desired light output. This method can be effective, but may have variations across multiple fixtures since the length of the control cable can affect the voltage level received at the fixture. There are 2 basic methods of using control voltage for light control: current sourcing and current sinking. In current sourcing, the control device will supply and send a direct current voltage to the device. In our example, sending 10 volts will cause the fixture to output at its brightest, and 0 volts will cause it to be at its darkest. Although effective, if the control wires are damaged, the fixture will appear not to illuminate. If the fixture uses current sinking, however, the fixture itself creates the DC voltage, and the control device only has to alter this voltage. Light-emitting diodes, or LEDs, being diodes, are essentially electronic switching devices which also emit light. They do not have a noticeable dimmed output and operate at very low voltages. In order to appear to dim, an electronic circuit is used to deploy pulse width modulation. This will turn the LED on and off in rapid succession, much faster than the human eye can detect. The ratio of time on and time off will create the appearance of a dimmed output. PWM controllers will require a constant electrical input in order to operate correctly. This controller may receive lighting level instructions remotely via control voltage or control signal. The most reliable and scalable method of controlling light output is by control signal. When using a control signal, similar to control voltage, the fixture must be provided with a constant voltage for operational power. Control signals are then sent on 2 or more additional low-voltage wires, usually in a digital format. This method allows for precise and replicable lighting output control. Some of the control signals that we use for lighting control include DMX, Dolly, and of course Crestron, which we will describe further in another section. This chart shows the different load types and their compatibility with the various forms of control that we have discussed. Note that each specific lamp and fixture may have different properties depending on its design, and proper review of the specifications is recommended before selecting a particular method of control. Thank you for watching.